Hello there. We're subtracting two-digit numbers today. But first, these questions should really get us in the right frame of mind. Pause the video to have a go. How did you get on with those? Subtracting the ones is easy. 4 subtract 4. If we've got 4 and we subtract 4, we're left with 0. Subtracting the tens, you could have used what you know for that one. And did you notice that both differences were the same on question 2? So the difference between 50 and 30 is 20, and the difference between 40 and 20 is 20. And then question 3, what happens when we subtract 0? Well, really, not a lot happens. 3 is our whole, we start with 3, and we don't subtract any, we're left with 3. 30 is our whole, and we don't subtract any, we're left with 30. Have you ever been bowling? 10-pin bowling? The pins are arranged like this. 1 at the front, plus 2, plus 3, plus 4. Altogether, there are 10. We are going to use the language first. First, there are 10 pins. Then 3 are knocked down. So first there were 10, then 3 pins are knocked down. Now there are 7 pins. First, there are 10. So our calculation starts with 10 as the whole. Then 3 pins are knocked down. So in our calculation we subtract 3. Now there are 7. So 10 subtract 3 is equal to 7. This language is really important, and you can apply it to any addition or subtraction problem where the amount is increasing or decreasing. Let's have a look. If our question was, there were 7 horses, and then 2 horses ran away, how many horses are there now? We can see the amount of horses is decreasing. So we could say, first there were 7, then 2 ran away, and now there are 5. Or maybe we had 30 children in a class, and 10 of them are going out to play, so our amount is decreasing. First there were 30, then 10 went out to play, and now there are 20. Jack loves partitioning, so when he sees 23 subtract 12, he thinks to himself, right, let's get 23 and let's partition it. And what he's looking for is a 10 and a 2, because 10 and 2 make 12. And when Jack finds a 10 and a 2, he can subtract those, and what he has left will be the answer. He first partitions 23 into 20 and 3. No 10s or 2s there. Then he partitions his 20 into 2 10s. Brilliant! He's getting closer. Then he partitions his 3 into 3 and 0. That's no good, Jack. You need a 1 and a 2. That's better. Now he can see a 10 and a 2. He begins with his 1s and subtracts 2, and then he subtracts 10. And what's he left with? 10 and 1, which is 11. So 23 subtract 12 is equal to 11. That's really nice partitioning, Jack. Great work. We'll look at column subtraction now. Here's a subtraction calculation for us to have a look at. 46 minus 13 is equal to 33. What's really important with column subtraction are the 10s and 1s. So let's bring those 10s and 1s together and think about where our 46 goes. 4 tens, 6 ones. We've got our minus symbol to show that we're doing a subtraction. And our 13, making sure our tens go in the tens column and our ones go in the ones column. Here's our equals sign and our answer, 33. Again, making sure the tens go in the tens column and the ones go in the ones column. Right, it's our turn to have a go at some column subtraction. 46 minus 22. What's the first thing I should do? Yes, get some equipment or draw some. Okay, 6 ones. Should I get 2 ones as well? As the first part of the calculation is going to be 6 ones subtract 2 ones. No, that's right. When we do subtraction, we only represent the whole, in this case 46. The 2 is going to be subtracted from 46, because 46 is being reduced. The number is going to get smaller. So we start with 6 ones and 4 tens. And we don't need to get an extra 2 tens and 2 ones. I've shaded out 2 ones to show that I had 6 ones and it's being reduced by 2. If I've drawn my base 10, I might cross them out to show that we had 6 and we've subtracted 2. I've got 4 ones now. Where should I write that 4? Pause the video to have a think. That's right. The 4 has to go in the ones column. And now we move on to the tens. I've got 4 tens and I'm subtracting 2 tens, which leaves me with 2 tens. 46 subtract 22 is equal to 24. And I can see that with my manipulatives. I've got 2 tens and 4 ones. Mo has 25 apples and Dora has 12 fewer apples than Mo. Let's have a look at Mo and Dora. Okay, how are we going to represent this? I could draw Mo's 25 apples, but that maybe isn't the most efficient method. Perhaps I should draw a bar instead, representing 25 apples. Now Dora has 12 fewer apples than Mo, so her bar is going to be smaller than Mo's. I'm not sure how many apples Dora has at the moment, but I do know the gap showing the difference between Dora's and Mo's is 12, because Dora has 12 fewer apples than Mo. I can't draw a bar there because the bars represent apples. Mo has 25, we're not sure how many Dora has. The 12 shows that Dora has 12 fewer apples than Mo. But there aren't any apples there, are there? Okay, let's do our calculation. Tens and ones, very important. We've got Mo's 25 apples, and we need to subtract the 12 to see how many apples Dora has. Use a ruler to draw my equal sign. Okay, now I need some base 10. 5 ones and 2 tens for 25. So 5 subtract 2. This time I'm going to put the cubes in a box. That way I can see how many I've subtracted and how many I've got left. I've got 3 ones left. I'm also going to put the 10 rods in the box. I'm starting with 2, subtracting 1, goes in the box, and I'm left with 1. 25 subtract 12 is 13. Dora has 13 apples. if I wanted to know how many apples they had altogether, I could add 25 and 13. You could have a go at that, if you like.